Hi friends, today I'm going to show you how to simulate an inverter by using a custom designer, that is a Synopsys tool. So I am creating a folder here and just giving the name as inverter underscore or test underscore inverter. So here you can store your projects. Before doing this, you have to create you have to give a library a description file. Okay, so that I have to set, and already have created that, and that I have specified all the libraries which should be used for this project. Okay, and this is not required, and I have to create a new library, so it will be added after updating the project. So next here I'm opening a terminal. So right click and open in terminal, then custom designer. You have to type custom designer. So it will open a Galaxy custom designer. As you know, this is the tool which is used for IC custom designs. This tool is from Synopsys. So this tool is opening now. So here this tool has been opened now, and you have to open library manager, that you can open by clicking tools and library manager. And here you can see that in the left side there is a default libraries that is having the default tools for simulating circuits. Now we are going to create a new library, and naming as inverter and test underscore test, and you have to attach uh, technique sorry tech this tech library. So you have to choose a tech library. Okay, actually I supposed to choose tech library, so you have to choose NCSU tech library. So this library has been created, that you can see here now. So next you have to create a cell view. So go to file and cell view, and you can type here inverter underscore test underscore DC, any name you can give here. First I'm going to analyze the DC characteristics of inverter, so I given the name as inverter underscore test underscore DC. Okay, so next I have to open this into by using a schematic window. Okay, so what you have to do is you have to open this in a cell view manner. Okay, okay, go to file and new cell view, and you can choose this view name, sorry, this editor as lay as a schematic editor. Okay, and give okay. This schematic window has been opened. So here you go to this add instant, and select NCSU device free PDK45. So inside of this you can see different kind of transistors, that is nothing VTH, VTL and VTG, that is nothing general voltage thresholding, and high voltage thresholding, and low voltage thresholding. So for our simple inverter, I'm going to choose this general voltage thresholding. Okay, you can click W, and you can connect this wires. So next I'm going to add this VDD and ground as well as VDC. So that is available inside of analog library, and you can type inside of cell as GND. So this it will give GND port, and again VDD, So you can drag and you can connect that on that terminal. Okay, that's just, you can press F, so this design will fix. Okay, so you can see all this design in a comfortable manner. Okay, now you are going to connect this substrate of PMOS and NMOS with to this corresponding power, that is I have connected. And next I need a VDD to power up this inverter, sorry, VDC. So I'm choosing this VDC, and already we have ground and VDD, so I can press C and just copy, and I can drag and I can connect here. So next we are going to analyze the DC characteristics of this inverter. So I need again one more DC voltage source, so that just again copied from this DC source which is available. So now I am going to give a name for input as Vin. Okay, and this voltage, I have to set a voltage for this. So this selecting I'm selecting this voltage source and pressing Q, and here giving 0.9 volt. So everything is connected now, and I have to give before that I have to make the changes, and I have to give output port name or output net name. So I'm giving v underscore out, and giving to that net. Okay, so everything is fine now. Now the circuit is ready for analysis, and next we have to go for analysis part. So in Synopsys, it's providing a tool that is called SAE, that is simulation analysis and environment. Okay, so here you can analyze your circuit, like various analysis like DC analysis and transient and similarly operating points, so that you can do. So here I am selecting DC operating, or sorry, DC characteristics. So as already I explained, so here this DC source is used to sweep. Okay, and I am selecting linear sweep steps. Okay, and giving starting point from 0 to 0.9 volt, that's a maximum voltage, and step size I am giving 0.01. Okay, apply OK, and now the output should be selected from schematic. So you can go to output, select in design. So you can choose this nets which should be displayed in your waveform window. So you can see that it is displaying in output window. Okay, so now various options are available in the right side of SAE. So there you can run, you can give a netlist and run. So that is nothing, it will create a netlist, and by using HSpace tool it will simulate. Okay, I'm giving again checking all the components of circuit which I have designed. Okay, then I'm executing now. So it's calling the HSpace tool, and it's running. So it's failed. I think the circuit have some minor mistakes, so we have to check that. Okay, so now you can see that I think the thing is I didn't set that model library. Okay, so I have to set a model library, that is very important. Okay, and in this I am using a free PDK, that is NCSU of PDK, which is used for educational purpose. Okay, so that library I have to choose, that is nothing, not library exactly, from that library I have to choose the transistor models. Okay, so that is available inside of free PDK and NCSU base kits, and inside of models HSpace tran models. So inside of this, as I explained previously, four kind of transistors available. I selected general transistors, so I am choosing PMOS and NMOS .inc, that is include file or model files, and giving apply and OK. So now I have to netlist and run. I have to press. Okay. So again, it's executing HSpace. It's finished completely, and you can see this output. If you're double clicking on that text, that is finished text, then you can get this particular window. And here we have used custom wave view. This is also one of the Synopsys tool which is used to analyze the timing or waveform analysis. Okay, grouping, and here some problem is occurred. Because of that output we are not getting properly. So here you can see that VIN is not connected properly. I think you have to connect that in a proper manner first. Okay, so we have to do that first. Okay, so I'm just have to delete that terminal or that wire first. Okay, so before that you can press G. Okay, that is available. You can press G, that is marker browser. So it will show what is the reason of that error or warning. So you can see that is specifying the floating instance, that is nothing, it's not connected properly. So I have deleted that, and again by pressing W I can connect that again. Okay, next I am giving the input terminal name, that is VIN. I'm typing and I'm giving. Okay, then applying, that is very important. Okay, so you are applying the changes. Okay, and again you have to save, that is it will check for any errors. If it is your design is having any error, automatically it will display the errors. Okay, now again you can execute. Okay, so it's running again. Yeah, it's showing the output. Okay, so this is the characteristics of a inverter based on DC characteristics, DC voltage. Okay, so you know this, I think everybody knows about this concept. Okay, so here almost 0.3 to 0.4. Okay, it's 0.35 to 0.45. It's almost non-linear operation. Okay, so you can consider that as a threshold voltage for this inverter. Okay. Okay, so this is the characteristics of a DC transistor. DC characteristics of a inverter for a single width. Okay, now we are going to analyze this transistor characteristics for different width. Okay, so that we are going to analyze. So for that we have to use a variable. Okay, instead of this width we have to specify a variable name. Okay, so just that I'm going to specify here. So you can see that so by pressing that by selecting the transistor you can press Q, and in the width I'm giving a variable name, that is a W underscore VAR, or any name you can give. Okay, and near to that it is giving M. So you know width will be always specifying in meter, so it's a very less value, less metric, like nanometer, micrometer, something like that. Okay, so we have given the variable name. Okay, now we are coming to SAE window, and we are adding that variable. Okay, so edit variable, and here click to add. So that variable name you can type directly here, otherwise you can choose from, you can take from the design. Okay, just you can press that particular push button, so it will automatically, it will get that variable. So I didn't save this, so it is not affected. So just again, after applying that pressing the tick I pressed, so here I can get that that variable name. Defaultly I'm setting the variable as 90 nanometer width. Okay, anything you can set. Okay, I think you can see that you can display in the W variable, yes, in the output as output window, and sorry, variable window, and you can you can see that. Okay, it's added. Now we are going to tools, and actually for changing this or for varying this parameter or variable, we are using parametric analysis. That is one of the tool which is used in SAE. Okay, so here we are going to vary the width. Okay, so W variable I am going to choose. Defaultly the temperature will be there, so you can change the temperature, and for some cases we have to change the temperature, and I'm changing that I have to decide now what is starting and what is ending. Just I'm giving 90 nanometer as starting, and stopping as I can give 180 nanometer. Okay, so 180 nanometer as ending, and number of points you can choose. For example, 90 to 180, you can consider 10 or 9 or 10. So based on your revision, so I'm just considering 10 points. Okay, 10 points I'm considering, and you can give okay, and everything is fine. Now you can go for yeah, you have to save the design first, then you can come to netlist and run. You can do that, so it will execute and it will give the output. So you can see this parametric analysis is running for different width. Okay, so that you can see here. Yeah, it's finished now. Okay, so for a different width, the DC characteristics from the DC voltage of 0 to 0.9. Okay, and you can see that output in wave view software. Okay, so this you can analyze. So for your design, so which width will be suitable, also that kind of analytical things you can do by using this technique. Okay, so now you can see this. So again, if you want to separate, you can select this and you can ungroup, so it will comes into different windows. Okay, so you can see that for different width what is the color. Okay, for 90 nanometer what is the color. So for different width what is the color you are getting, and you can easily identify. Okay, so this is for you are getting for different color, and so different for a different width. So you can separate this again, so like this, select this and you can ungrouping means, so automatically this will be separately you can get. So if you want to analyze separately means you can do like this. Okay, So next we are going to analyze. So now I am going to save the state. Okay, so in the future, if I want to execute this again, I can load the state. So I don't want to set again this variables and that step size, those and all not required. You can directly load the state, so easily you can execute. So next I am going to save a copy, and I want to execute for transient analysis. Just I'm giving tran, okay, and it is storing inside of inverter testing library, okay. And I'm going to close this, and I'm going to open that particular file which I have saved now. So that is available here. Just I'm going to open this, okay. And now I am going to analyze this one by using transient, that is a timing analysis. So I need a pulse generator that is available inside of analog libraries, and here you can get vpulse, okay. And symbol, I am choosing a headspace or a symbol you can take, okay. And just I am connecting that and selecting that and pressing Q, and here I am changing the parameters like voltage and a period and like a duty cycle, that is that is period, and time, that is pulse width. So that and all I'm setting. So here I'm setting a 0.9 volt, okay, and voltage 2 will be 0, and false time should be less, so I'm giving 1 pico, and rise time and false time, and pulse width that I can fix to 50 micro, so that's your wish. And period you can give 100 micro, okay. You can apply, and you can run now. Yes, you can go to SAE and going to select transient, okay. Tran, that is not required. Tran I am selecting and giving a time step, that is I am giving 1 nano based on your wish, but that if you are giving lesser time step, it will take longer time, okay. So then stop time, that I can give almost